Hello again. Today we'll look at indice laws and then follow that later with log laws. So indice laws are something that many of you may have seen before. We'll formalize this, look at the laws and see how to use them in various problems. First of all, a little bit of philosophy for the day. The difficulties of life are meant to make us better, not bitter. So always remember that you're there to make you better, not bitter. So don't turn hard against life. Life will treat you the way it wants to. It's how you respond to that matters. So indice laws. The notation we use here essentially is if I'm multiplying something by itself, then I write that as a power as we have over here. So I've got 2 to the 4 essentially means I multiply 2 by itself 4 times. And for any positive integer x, 2 to the x means I multiply 2 by itself x times. So that's basically all that's happening with indices. The laws here are fairly obvious in many sense, but let's have a look at them to make sure we understand them. The first is if I have ax times a to the y, that becomes a to the x plus y. Ax divided by a to the y becomes a to the x minus y. If I have a to the x then to the power y, so this I can write essentially as a to the x and then to the y. That's the same as a to the x times y. A to the 0 is 1. AB to the power x is the same as raising each of these to the power x and then multiplying. So a to the x times b to the x. Similarly, a over b to the x is a to the x divided by b to the x. A to the negative x means 1 over a to the x. So the negative power means essentially 1 over, reciprocal essentially. And a to the 1 upon x means the x root of a. So when I write something like a to the half, that's the same as square root of a. And for example, a to the third then would be the cube root of a. So those are the laws. You need to understand how they work and be able to apply them. They aren't so hard to remember. So here, the notes essentially work out how these laws actually work. So take a look at the first one. It said essentially the first law was a to the x times a to the y was a to the x plus y. So if I certainly just write this down in full, I get from the first one a times a x times, and then I have another a times a, but this time is y times. And so my notations, so I've got altogether x plus y a's there, and that's why it becomes a to the x plus y. The second rule here is a to the x divided by a to the y. So similarly, if I take a look at a to the x divided by a to the y, then I'm going to have x lots of a over there, all over y lots of a over there. And if I cancel them off one by one, what I'm left with is the difference between those. So if I have altogether x minus y a's left, because I cancel y of those from the top, I get that many left. The third rule says a to the x to the y is a to the y. Let's say it's a to the x. If I then raise it to the power y, I get a to the y. And all I've got here is essentially a to the x times a to the x y times. And if I use the first law, essentially I'm going to add all the x's up and I get y lots of this, so it's a to the xy. The fourth one says a to the 0 is equal to 1. And the way that it works is, if I take a look at a over a and use the second rule, that becomes a to the 0. And of course, a over a is equal to 1. So a to the 0 must be equal to 1. The fifth one says a to the ab to the x. And so here, if I write that down again in full, what that is a times b, and then again a times b, and I have this x times So if I separate those and put all the a's together and then all the b's together, I have x lots of a and x lots of b. So that becomes a to the x times b to the x. The sixth one says a to the negative 1, not quite, sorry, a to the a over x, a over b to the x. So a over b to the x works in the same way as before. This is exactly the same as number 5, but now I've got a over b here. Now I've got x of those. So clearly I can look at the top and the bottom separately, and I'm going to get x of the a's and x of the b's. Now step 7 is taking a look at 1 over a. Now that's actually a to the 0 over a to the 1. And if I use my law, the second one, that becomes a to the 0 minus 1. That's a to the negative 1. So that is a to the negative 1 becomes 1 upon a. And the 8th one is to do with the roots. So if I'm taking a look at a to the 1 over x, if I raise that to the power x, I get a to the 1. That means a to the 1 over x must be the xth root of a. So that was essentially proofs, if you like, but it's nothing more than just the use of the notation correctly. So here are some quick evaluations. 27 to the third. To do this properly really requires me to write this 27 as 3 cubed and then to the third. And then when I multiply the powers here, a to the x to the y is a to the x times y. I get 3 times the third is 1. I get 3 to the 1, and that's equal to 3. Similarly, 64 to the third is 4 cubed to the third, and that is 4. And 216 to the third. Now that's a bit tricky. If you don't know the cube root of 216 straight away, that can be a bit tricky. What we do is actually expand this 216 out. So I can do a bit of a scribble here. 216. Well, I know that's going to be, if I divide this by 3, I get 3 times 72. And that becomes 3 times, and 72 is 9 times 8. And now I'm getting the idea here. This is 3 cubed times 2 cubed. So I can write this as 3 cubed times 2 cubed all to the third. And my rule says I'll expand this separately. That just gives me 3 to the 1 times 2 to the 1. In other words, I get 6 out of this. So if you can't express something very quickly as a power, break it up into its factors and then pick up the upper powers from there. Likewise, 81 to the 3 quarters, this isn't so bad. We know that 81 is 9 times 9 to the 3 quarters, and then so this becomes 3 squared times 3 squared to the 3 quarters. If I can take it one step further, this is 3 to the 4th, then to the power 3 quarters. In these situations, we try and take the root first because that makes smaller numbers. So obviously 3 to the 4th, 3 to the 4th times 3 quarters, essentially the 3 quarters times 4 gives me 3, and that is 3 times 3 times 3, 27. That's how this works. Just using the rules. So more over here in terms of some variables. So here the numbers multiply, so I get 2 times 3 is 6, and then I get x to the 1/3 plus 4/3, so that gives me 6x to the 5/3, and that's how I leave it. If, similarly, I can write this 16 as 2 to the 4th, then times x to the fourth, then to the half. So 2 to the fourth times a half is 2 squared, and x to the 4 times a half is 2, so it's 2 squared x squared, that becomes 4x squared. The next one might look a bit more horrible, but let's have a look. We know 81 is 3 to the 4. Let me just change that, 3 to the 4th. And then I've got x to the 3rd. The 9 is 3 squared, and x to the minus 2 to the negative a third. That should be a power here, a small typo which I'll have to fix. Negative a third, there's a power. And so the negative power means this goes to the top as a positive power. So I'm going to get over here, the top line as I have it, which is 3 to the 4th times x to the 3rd. Then I get 3 squared times x to the negative 2 to the positive 3rd. So that becomes 3 to the 4 times a third is 4/3, x to the 3rd, 3 to the 2/3 again, and x to the negative 2/3. If I add the powers up, I get 3 to the 6/3, and I get x to the negative a third. Now 3 to the 6/3 is 3 squared, that's 9. That's 9 times x to the negative a third. And you can leave it like that, or you can write the thing as 9 over x to the 3rd, either way. Some more here that look a bit more difficult. And when we finish this off in the next part of the lecture, you can try this yourself first before you look at the next lecture. Thank you. Bye-bye.